My name is Alois Saria. I'm from the Medical University of Innsbruck in Austria, and I'm coordinating the education and training program of the Human Brain Project. And this is actually why I'm here today, and because the Education Program Office has co-organized this workshop together with colleagues from the Alois Institute. I'm going to briefly introduce the Human Brain Project, in particular the current status of the project. This is what I want to do today. And I have to give credits to two colleagues for this presentation. First of all, actually concerning the program of this workshop and also of this afternoon, credit goes to Jean-Hill, who has actually been most active in putting together the program jointly with the Alois Institute, and to the co-chair of the Science and Infrastructure Board of the Human Brain Project, Karl-Heinz Meyer, who allowed me to use a couple of these slides. So, where do we stand today, and where comes the Human Brain Project in? You probably know this figure from a paper by Shenovsky and colleagues, showing that modern neuroscience actually is able to cover nowadays 7 orders of magnitude in scale, in metrics of the brain, and even 11 orders of magnitude in time resolution. So we are actually we do have access to multiple scales in space and time. And the Human Brain Project actually does want to tackle this, to use the tools and develop new tools, computing tools as well, to investigate the brain on all those scales. And also when it comes to computing, the second major vision and goal of the Human Brain Project is to develop, if you wish, brain-like computing. And modern computing at this moment is adopting, in fact, more and more brain-like principles, which means that it's about the right time to go along this line. The messages from the European Commission, and that's a reason why the European Commission has taken up also this flagship idea and develop these projects further, with knowing that research infrastructures play an increasingly important role in the advancement of knowledge and technology. So it's infrastructure, and it's about infrastructure. And another citation says, a more rigorous infrastructure building and operating approach is needed for ensuring success in translating the ICT platforms into a solid European infrastructure. And that relates to the elements of the Human Brain Project. Actually, this project is in fact a combined research and infrastructure project, and it's going that way. Infrastructures, we know, are at the center of knowledge triangle of research, education, and innovation. So these are the actually main and most important elements of the Human Brain Project in Europe. So the basic idea is going from science to infrastructure, and using infrastructure again for science and innovation. And within the HBP, the infrastructure is composed of 6 so-called platforms, which are the neuroinformatics platform, the brain simulation platform, the high-performance computing platform, medical informatics platform, neuromorphic computing platform, and neurorobotics platform. And these platforms are fed not only by big data from the global community, but also by additional co-design projects within the Human Brain Project on neuroscience, which relates to the mouse brain, to the human brain, cognition and to theory. So as mentioned, we have these 6 platforms in the HPP. Neuroinformatics to aggregate the data and deliver brain atlases. And of course here it's also one of the links to other organizations such as the Alois Institute. The medical informatics platform is supposed to aggregate clinical records and to classify brain diseases. The simulation platforms is about developing software tools, run closed-loop brain simulations. And then there's this high-performance analytics and computing platform. This is about developing and operating HPC systems optimized for analysis and simulations. We need this high-performance computing power once a project develops and we get more and more into larger simulations and calculations. And the neuromorphic computing platform is about developing and operating novel brain-derived computing hardware. And last but not least, the robotics platform is to develop virtual and real robot systems for closed-loop cognitive experience, to give these computer brains a body, if you wish. So in the past year, which was the year 2 of the HPP, co-designs, these so-called co-design projects have been structured, and they are about developing a whole mouse brain model and brain atlas. Then about mouse-based cellular, cortical and subcortical microcircuit models, and a couple of more you see listed on this slide. And what this slide should show you is, if you look at the red arrow, that these co-design projects meet one of the major flagship objectives of the European Commission, which is to create and operate a European scientific research infrastructure for brain research, cognitive neuroscience, and other brain-inspired scientists. And the red stars you can see on these slides are indicating the different platforms that are used or involved in these so-called co-design projects. So an example workflow is shown here. For instance, the sub-project 5 integrates data, the neuroinformatics platform is used for circuit building simulations in the sub-project 6 for the simulation platforms, and exported to the neuromorphic platform, the so-called sub-project 9, and fed into the robotics platform from both two sides. And for instance, the neuromorphic platform would be fed by information and data coming from co-design projects, for instance, in this example, CCDB 5. Just a few months ago, or even weeks ago, on the 30th of March, there was a big platform release event. Actually, that was the end of the so-called ramp-up phase of the Human Brain project, where all 6 platforms, at least in the preliminary version, were released. There was a public release event, and there were live videos available where colleagues, also not only from the project but also external scientists, could join in and could look at that. So talking about external community, that means this is actually what the platforms will be for the whole scientific community. And there are actually several ways to become a user of these platforms. First, and most important, through a central platform that's called the Collaboratory. And the access can be either from the public or through the HPP identity, or one could apply for a test access, project access, or through partnering projects that may be financed by other sources. So there are a variety of possibilities to actually become a user. And looking at the number of accounts that have already been registered for the platforms, you can see here that since the public release of these platforms, several hundred users have already got access and received accounts for these platforms. That's just the statistics that the drop machines we need to look at. So finally, at the end of my part of the presentation, I would like to express some words of caution, because sometimes we realize it's seen that, okay, these will be computer platforms where you can get in and you press a couple of buttons and then you get a big result. They are not click and work platforms. They require serious long-term personal engagements. The users do not appear by chance, so it is actually essential to recruit actively high-quality users and train them, and support will be essential. And the leaders of HPP think that the typically successful users will be young scientists or postdocs which will be working in the HPP or together with the HPP for many years. So that's about the overview. Now coming to this afternoon. For the rest of the remaining time of the afternoon, you will be there will be demonstrated some ways of how to work within the Human Brain Project, to use certain tools in practice, and the colleagues who will be the leaders of this afternoon are Werner van Geel. He will presenting optimization methods for single-cell modeling. Christian Rössert, who joined the Blue Brain Project in 2014, also from IFL now, presenting advanced modeling of cortical and hippocampal, pyramidal and interneurons. Then we've got Elif Muller, now also in Switzerland, who will inform us about modeling cortical microcircuitry. And finally, Elisabeth Jarone, also from EPFL, who will help in the tutorial 3 with Werner van Geel and Christian Rössert on the topic HPP neuroinformatics and single-cell modeling. Thank you very much. And I would like to just hand over to the first active speaker.